So my name's Lauren. I've been tutoring this course for a billion years, specifically almost 12, I think, for this course. I love stats. I also do the crash courses for COMM 295. That's in second year, first term. That's managerial economics. But let's focus on stats. I love stats. I did business, and I also did level 3 advanced Excel courses. So Excel is my forte and stats. So hopefully you'll find this tutorial, these weekly tutorials worthwhile. So just to be very clear, all your assignments require a lot of Excel functions, but some of these Excel functions may not be used for the midterms. And this may be too soon, but I believe in previous years, and I think this year as well, the midterm and final exams are open book, and you're allowed to bring in an Excel spreadsheet. I call it the dashboard, because you're allowed to pre-formulate all the Excel stuff so that when you write your exam, you just have to input information into the Excel function and automatically calculates everything. But I know your mindset's not at midterms yet, but yeah, it's very important you walk into the midterms and final exams with a souped up dashboard. You don't want to do this from scratch. You don't want to be entering formulas on the midterm and finals. But if you go to my crash course, and I hope you do, it's a little more fast paced, and it'll be like week 7 or week 8 by then. Then my expectation of you is that you'll have some basic or more than basic understanding of stats. But because only week 3 today, I will be slower, but don't get used to it. Okay, so on the assignments, and some of these you might know already, some of these you wish you learned it for this week's assignment. If we have time, then we'll do more formulas for next week's assignment, because I have a sense of what they'll be doing next week. Anyways, let's go over, so we'll go over some of the Excel formulas first. Then we'll talk about a brief review of variables and data and measurements. Then we'll do some analyses of charts and graphs. And if we have extra time at the end, we'll make it open-ended. You can ask me anything, like any extra formulas you want me to teach you. I'm pretty sure I can do them. But yeah, so the tutorials aren't as structured as the crash courses, and they're not as fast-paced. So feel free to ask me questions. I will occasionally look at the chat. But yeah, if you have any questions, put it in the chat. And I may not see it right away, but yeah, put it in the chat room, because I have 2 screens right now. One is what I'm going to share for Excel, and that screen is my solutions. And then there's another screen below me where I'm going to write stuff. So my volume's good. You can see me write and stuff. Okay. Okay, let's begin with the Excel functions. The minimum one's very easy. We have the min function. Then we have the quartile function, which is quartile bracket. And then anything blank is stuff you highlight. And then the stuff you highlight, the Excel function will calculate the first quartile when you indicate comma 1. So that's for Q1. You can also call it the 25th percentile. So the bottom 25% of the data set. Then you have the median. So to be very clear, the median is the number located right at the middle when you rank the numbers from lowest to highest. Unlike the mean, which is down here, the mean is the average value of all the numbers in your data set. And depending on the distribution, the mean may not be equal to the median, because some data and most data are slightly skewed or very skewed. They're equal when the mean and mean are equal, then the assumption is that the distribution is symmetric, assuming it's unimodal. And then Q3, the quartile comma 3, that is to solve for the 75th percentile. And then the max will solve for the largest number in your data set. And notice in the tips column, I indicate that these 5 measurements are used for the 5-number summary. And those are used for box plots. And I think you learned box plots already. So a box plot will look something like this. And let me add something called an outlier. Here's 2 outliers. You have the minimum, you have the quartile 1, you have the median. Here's quartile 3. And where's the max? Okay, this is not the max, you guys. So make sure, just because you see a whisker, this is not the max. The maximum is literally the largest number in your data set. This is the max, assuming that there's an outlier that's very large. Someone asked, are we using Excel for midterm? Yes, you are. Dr. Berkowitz says we don't need to. You don't need to. You can use these crazy formulas and solve by hand, but guess what? You probably won't finish the midterm. I had a student last year, and I'm going to refrain talking too much about the midterm because that's not until a couple of weeks. I had a student who's super smart, straight A student. She refused to use Excel. She did not use Excel. She walked into a midterm. She couldn't finish it. She got a C+. And for her, a C+ is a fail. And she got every question right up to the last question she managed to finish. So because she didn't finish the midterm, she got a C+. So my advice to you, if Excel is allowed, I think it is, please use it. Okay, so these 5 are for the 5-number summary used for box plots. These formulas are very useful for your assignments. It was very useful for the assignment that was due on Wednesday, I think. This will continue to be very useful formulas. Count is very easy. Count literally just counts how many variables are in your data set. You can also call that n, or sample size, or number of observations. You'll notice in stats, we have several terminology for the same crap. Countif and Countifs with the S are super important and super useful. Countif is a conditional counting. It says only count whatever fits this criterion. So I use theta, doesn't matter what I use, but Countif means given this data set, how many of those have this specific criterion? For example, equal Countif and then A:(A, 3. And I'll show you all this on an Excel spreadsheet later. This means you're telling Excel everything in row A, how many have the value equal to 3? So that's a very, very useful formula. So it has to be equal to 3. Any number that's equal to 3 will be counted. Anything not equal to 3 will not be counted. Countif is a super important one. It's a bit crazy, but once you get a hang of it, you'll love it. And I personally love it so much. So for example, Countifs, because it is an estimate, you have multiple criteria. Only count this variable if it fulfills this criteria and this criteria. You must fulfill both criteria in order to be counted. For example, count if that value has a value of 3 in row A and a value of 4 in row B. You must fulfill both these criteria in order to be counted. And this will make more sense once we do an example on Excel. The second one here is pretty insane, but look at this. Count if in row A, this value is equal or greater than 10 and equal or less than 20. So what that means is we're counting this if the value is between 10 and 20 inclusive, because I indicated greater or equal or less than equal. So if you're a 10 or if you're a 20, you will be counted. Conversely, we have this. Countifs is greater than 10 or less than 20. This is non-inclusive, where X is between 10 and 20, but not equal to 10, not equal to 20. So if I'm 10, I will not be counted. If I'm 20, I will not be counted. But I have to be a value between 10 and 20, non-inclusive. Does that make sense? It's very important because if you don't indicate the right equal sign or not, you may add up values that you don't want to add up, and vice versa. Again, we'll do examples later. There's a tab in my Excel spreadsheet that's dedicated to the Countifs function. If not already, make sure you download the Excel function, the Excel spreadsheet that I already provided, and we'll fill those out together. And there will be chances for you to try these examples by yourself. Okay, so those are the super important ones. The other ones are not too crazy. This one, mode, from the first lecture, mode is the value that appears the most. So if I do 1, 1, 1, 2, 2, 3, then the mode will be 1 because 1 appears the most. So that's the easy one. And like I said earlier, average talks about the average value of all the data. So you add up everything, divide by the number of observations in that data set. Standard deviation. What does standard deviation measure? Standard deviation measures how spread out the data is from the center. So the larger the standard deviation, the larger the spread within that data set. And when I mentioned that they're non-resistant, what does that mean? It means that when I add crazy values or extreme values, aka outliers, to my data set, the average and the standard deviations, both those values will change a lot. So they're very sensitive to extreme values. So if I add a very small number or if I add a super large number into my data set, right, the average and the standard deviation values will change a lot depending on those values. And this one, the sum, a very important one, it literally just adds up the values, the total values of every value in the data set. So unlike count just counts how many there are, whereas sum adds up the values of those observations. And these two are not used very often, but they're also very useful. ABS, and I lost all my ABS since COVID. ABS, it does not mean ABS, it means absolute value. So if I highlight all my data set and then make them all equal ABS, that means that just converts all the negative values into positive values, and the positive values don't change, they remain positive. So if I do ABS bracket -79, then it just transforms it to 79. And lastly, we have square root, SQRT, and that takes the square root of the corresponding value. So square root bracket 256 equals to 16. So just like that. So those are the basic but also very useful formulas for our Excel. Okay, so let's go to our Excel spreadsheet. And like I said, you should have already downloaded it. And I'm going to alternate between this screen and also the Excel screen. But for the most part, we'll be using the Excel screen. Okay, let me just convert it. Okay, can you guys see this? Is the font large enough? Let me do a little bigger. How's that? So my policy is if I don't see students panicking or screaming on the chat, I'm going to assume you guys are okay. Okay, good. Okay, so here's an example, and this might be, the funny thing is, after you finish this course, a lot of these formulas you will never use when you graduate from solder. After I finished my undergrad, I'd never use like 99% of these formulas, but I find the basic ones, those are the ones I use the most for work. Okay, so here's an example here. We have these super long list of items. As you can see, it's crazy. It's absolutely impossible to count these by hand. I hope you did not do that for the assignment. Please don't ever count anything by hand. And then you have the statuses corresponding to these items. There are 5 different types of items. So 1 for shirt, 2 for jacket, and all the way down to 5 for shoes. And statuses, 0 means they're reserved, 1 means they're paid, and 2 means they're delivered to the customers. So 3-1 means these pants have been reserved, but not paid, not delivered. Okay, let's do this. What item is the most popular? What are we looking for here? And if you feel brave, like say in the chat, how do I solve for the most popular item? Yes, correct, mode. So literally equal, I hope you can see my formulas, mode. And what you could do is just highlight everything from D2 all the way down to D infinity. But Excel's smart enough that when you just click on the entire row, it will exclude the title item. So item is not a value. Excel will not count item. So it's mode and then click on the entire row. And you could close bracket, but if you don't close the bracket, Excel's smart enough to know it's still going to count. It's still going to work. So it's 5. Someone wants me to zoom in a little. Absolutely. Is that okay? And to double check your values, you can double click on the cell and then you can see the formula. Okay, so that's an easy one, warm up. How about this one? How many items are reserved? And by the way, when I do these, try it out by yourself too. How many items are reserved? So we want reserved is status 0. So basically, we're going to use the conditional counting, count if, and there's only one condition, only if they're reserved. So it's count if without the S, count if bracket, and then I'll click on the entire status status column, and it's asking for the criteria. The criteria is that it must be 0, like that. And it's not the count function because the count function will count everything. So it's given row E, how many are 0? So close the bracket, and there's 48 items that are reserved. If you're curious, how many items are there? I could do count and then do this. And I know there's 137 items in total without any conditions. There's 137 items, but 48 of those 37 are reserved. It's pretty useful, right? And this will get crazier and crazier. How many shirts have been delivered? How many conditions are there? Has to be shirts and has to be delivered. So we only care about shirts that are delivered. So it's 2 conditions. So we need to use the countifs function. By the way, countifs is not limited to 2 conditions. You can have 60 conditions, right? It'll get crazy, but it's possible. So I'm going to use 2 conditions, countifs bracket, and please try it out. And notice it's asking for multiple criteria. The first criteria has to be shirts. So I'm going to click on the item and comma. Don't forget the commas. Shirts are item 1. And then again, comma. Now it is asking for the next criteria. Has to be delivered. So I'm going to click on the status column because that tells us whether it's delivered or not. And deliver is status 2. So comma 2. And that's it. Has to be 1 in row D and has to be 1 in column D and has to be 2 in column E. That's pretty much it. There you go. There are 6 items in total that are shirts that have been delivered. 2 criteria. So I'm sure you guys wish you learned that for that assignment. And that second assignment was a lot of work. I'll admit that. Okay, you guys go to this. Okay. How many pans have been delivered? How many pans have been paid or delivered? Why don't I give you guys 30 seconds to try this one out? How many pans have been paid or delivered? So when you learn from COMM 290, what does or mean? It's the addition rule, right? Okay, so I'm assuming you guys had ample time to try this out. How many pans have been paid or delivered? So we're going to do this. Countifs, and the first criteria is that they have to be pans. That's the easy one. So click on this entire column, and pans are 1. Oops, sorry, pans are 3. Pans are 3, yep. And the second criteria is that the status have to be delivered, paid or delivered. So what you can do is you can do equal. You can do 1 or 2. And then you can do, what do you call it? Equal or greater than 1. So that'll count 1 and also count 2. And then close that. And oh, I always forget that. You make sure you have the quotations. So here it says it has to be equal to 1, equal or greater than 1. It will count paid and delivered. So or delivered. And we get 19 here. Any questions here? Okay. So that's a warm up for the counting rule. Any questions? So let's go to the next tab. In the second tab, this is easy. We have 4 columns. The first column is subject number. So each subject in my study will be assigned a number. And then B is gender, male equals 1, female equal to 2. You can switch the 2, it doesn't matter. But in this case, 1 is male, 2 is female. When you learn this course, oops, one sec. I'm gonna turn off my, okay. When you learn multiple regression in the last chapter of this course, we call these dummy variables when you're assigned numbers to categorical variables because gender is categorical. And then we have rank, whatever that means. Rank could be what rank they are in their job. And then salary, it tells you what their salaries are. So subject number 1 is a female. She's in rank 1 and she gets paid 80 or $80,000. Subject number 7 is the male in rank 2 and he gets a salary of 101. So that's what this means. Okay, so do you guys understand the differences between nominal, ordinal, quantitative, and identifiers? So let's do a quick review. Let me share my screen on my tablet. So this is a quick review of data and measurements, because they will ask these questions on the midterm. And thankfully, those are pretty straightforward. Okay, so we have categorical variables and we also have quantitative variables. And quantitative variables are easiest because you can literally do math with them. You can add, you can subtract, you can divide, you can multiply. So quantitative variables are values that are quantitative that you can do math with, like income, your age, your weight, your GPA, and so forth. So those are quantitative variables. Categorical variables they take on qualities like hair color, eye color, customer satisfaction level, occupations, and so forth. And then we have something called identifiers. Those are just numbers and or letters or a string of both then their sole purpose is to identify people or things. So your student number, even though they're numbers, you can't do math with a student number. So if I divide your student number by 2, that means nothing. So your student number, your postal code, and your license plate number, those are all identifiers. Even though they look like numbers, and they are, you cannot do math with it. They're just identifying things or people. And then we have nominal versus ordinal. They're both categorical variables. But the difference is that nominal variables you cannot put in order, whereas ordinal variables you can put in order. So to be very cheesy, you can call it ordinal. That's how I remember the difference between ordinal and nominal. Ordinal you can put in order. You can rank them from highest to lowest. Even though they're not mathematical values, they're not quantitative, you can still put them in order. For example, bronze is lower than silver, and silver is lower than gold in terms of Olympic medals. Satisfaction level, you can rank it low, medium, high, and also level of pain. Mild, moderate, severe. Okay, so those are ordinal. Okay, nominals you cannot put in order. You cannot put religion in any rank that will cause wars. Occupation, ethnicity, right? You don't, those are not put in any order. Brand, and so forth. Okay, let's go back to the Excel spreadsheet. And I think we're going to stay on this Excel spreadsheet for the rest of the day. Okay, so if you feel brave, let me just put it in the chat. What is subject? What kind of variable is subject? Subject 1, subject 2, subject 3. If you want to put it in the chat, let me know. That will also indicate that you guys are still here. Oh. Let's go do it. I'm not sure what's happening right now. Can you raise your hand that you can still see all this? I just want to make sure this is happening. Okay, good. Then I will proceed. Sorry, it's my first class. Subject is identifier. So I'll highlight it. Because you can't do math, even though the numbers, like subject 10 is not twice the size of subject 5, that makes no sense. So they're just identifiers. Gender is is categorical, but which one? Can you put them in order? No. So it's a nominal categorical variable. Rank 1, rank 2, rank 3. And to be very clear, it is not quantitative. Rank 2 doesn't mean it's twice as good as rank 1. It's just higher than rank 1. Or you can also say rank 1 is higher than 2. We don't know. We don't know which rank's higher or lower, but we do know that they're different ranks. And some are larger than the other. So they're ordinal. And salary. Can you do math with salary? Absolutely. If my salary doubled, great. You can do that. And it is also good to double your salary. So salary is a quantitative variable. So that's how we identify different types of variables. Okay, let me enlarge this a little bit. How many people are in the study? So we're going to use what? The count. And it doesn't matter which one I highlight. I'm just going to highlight subject, I guess. So I'm just going to count everybody. And there are 400 people in the study. Easy enough. For rank, what is the mode? Easy. Mode. And then I'll click on the rank column. And we're going to see which rank appears the most. And that's rank 1. So my guess is rank 1's the lower rank. It's going to be very rare that you start at the high rank. So rank appears the most. Okay, pop quiz. How many are in rank 1? Let me add this right now, bonus. How many are in rank 1? So we do count ifs, highlight the ranks, and then rank 1. 141 are in rank 1. So that'll be your answer here. And don't worry, guys, this will get harder. Okay, now we're going to complete the descriptive statistics table for salary. What's the minimum value for salary? So who has the lowest salary, or what's the value of the minimum? So click on minimum and then click on the salary column. And the lowest salary is 43. And for quartile 1 is quartile, bracket, and then the entire salary column, which is D, comma, and then you got to specify the first quartile, which is the 25th percentile, 75. And then the median's easy, median. And we just keep doing that for the same column, because column D is always going to be salary. So 94 is the median salary, meaning that if I rank these salaries from lowest to highest, the middle, very, very middle one is $94,000. And then the third quartile, column D, comma 3. 116. And finally, the maximum is max, comma, and then same column. Whoa, that's crazy. Look at that. The person earning the highest is earning $855,000, which is insane. And right off the bat, do you know if data is skewed? Yes, because there's at least one super duper large outlier that's going to drag the distribution to the right, making the distribution skewed to the right. And you're going to notice there'll be more and more indications of skewness. What is the interquartile range? The interquartile range is equal to the Q3 minus Q1. And that will contain the middle 50% of the data. Because it's the 75 percentile minus the bottom 25 percentile, and you're left with the middle 50%, meaning 50% of my data will fall into the middle within the IQR, the interquartile range. So what you do is do equal, and then do Q3, this one, minus Q1, like that. And then equal. And the interquartile range is $41,000. And for the midterm, you should have something like this set up in advance, so that on the midterm, you just have to, like, whenever you modify a value, like make this 50, the IQR automatically recalculates, and that's what you want for the midterm, so that you can change these numbers, and then the way you want to solve will continue to adjust and recalculate. So I'm going to undo this because that's not the answer. Okay, so this is your answer here. So here's a 5-number summary. We can use these 5 numbers to generate a box plot, which is a pain in the ass primary language to do on Excel. I prefer doing it on software, not Excel. But Excel is great otherwise. What is the mean? The mean is the funny thing is, if you use the mean formula, it's not a formula. Equal mean is not a formula. I don't know why. It's super annoying. If I do this, it's not going to calculate anything. It's going to give me an error because Excel doesn't recognize mean. You have to use average. That's why you want to pre-formulate all your Excel dashboard in advance, so that you don't have to worry about remembering how to spell these stupid formulas, because they're great, but it's annoying to spell. You want to pre-formulate them, so it's average. Interesting. Notice that the mean is 100, but the median is 94. I'm going to highlight these. Since the mean is greater than the median, what does that tell us? The data or the distribution for a salary is skewed, right? To what direction? To the right. When the mean is greater than the median, the data is skewed to the right. And as you can see here, remember the maximum is super large. It's going to drag the mean upwards. And like I said earlier, the mean is a non-resistant measure of center. So when you add super large numbers like 855, it's going to drag the mean up, and thereby making it larger than the median. Therefore, there's indication that the distribution is skewed to the right. What rank is the person earning the highest salary? So I don't want you guys scrolling down until you find 855. That's silly. So what I'm going to do is use the Countifs function. So Countifs, actually, there's probably a faster way, isn't it? Yeah, I could, this is silly. Okay, look at this. I can just do control find, and I'm just going to put 855 here. And there it is. And that person is in rank 2. So I overthought it. You just have to do control find and find 855, and then that person in rank 2, which is insane. That person is not even rank 3, and they're earning so much. So let's put 2 in there. For the midterm, just in case you're wondering, for the midterm, you're not required to tell them what formula to use. They just need the answers. Okay, I know that in the assignment you're required to complete the contingency table. In this case, we're going to do it for ranks. Okay, so let's do it here. How do you count all the males that are in rank 1? So Countifs that they're males. Make sure you choose the correct column. Males in rank 1. So like that. So it has to be 1 in row column B and 1 in column C. And we have 90. And let's continue with the males. Countifs B male again, and then C level rank 2. So I'm sure some of you wish you learned this before your assignment, But again, this will continue. This form will continue to be useful for future assignments. Countifs, they're male, and rank 3. There you go. Okay, you guys go with this? How would you do the rank of the highest salary with the formula? Okay, so I guess if you're not satisfied with control find, what rank is the person earning the highest salary? Interesting question. Countifs, bracket, and then this column. And then I'll say equal. Ooh, not Countifs. No, I think that's a different formula. There's something called a VLOOKUP formula that's more advanced. So I'm gonna say VLOOKUP. So this is a VLOOKUP formula that I will teach you on another day. It's a very advanced formula, but it's a conditional search where it'll populate a certain value given a certain condition. That'll be it for another day. So if you're curious, it's a VLOOKUP function. If we have time later today, I'll show you how to do it. So we'll save this for later. Okay, let's continue with this one. Females. Count if female is a 2 in rank 1. And my philosophy is once you're bored of this, that means you get it. So I think by now you guys understand this formula quite well. So 2 in rank 2. Females in rank 2. There we go. Count ifs females 2 in rank 3. Like that. And obviously it's much faster when you're on your desktop versus your laptop. Okay, now we want to do the column total. So I just add up these two like that. And I get that. And at this point, there's no need to start typing. I'm just gonna copy, and you can copy this formula and I can paste it into these like that. So you can tell that this cell is the sum of these two cells, and this cell is the sum of these two cells. And I hope that they add up to 400 people. They do. Now I'm going to add up the row total. And these rows. There we go. And I'm OCD. I'm going to add up these two as well to make sure they're 400. And they are. Great. Now our contingency table is complete. Okay. Any question on this? That's way faster than put them in order and then highlighting and counting it. Right? You don't want to do that. So that's how you complete it. Now it looks to me that the ranks are pretty evenly distributed. It's hard to say because there are more males than females in my sample. So it's hard to eyeball it. But to me, it looks like the distribution is pretty equal, especially when you look at the column totals. Okay, what percent of people are in rank 3? You want percent, not counts. So amongst those in rank 3, what percent are, so everyone in rank 3, there's 118 of them, divided by the grand total, which is 400. So there you go. So that divided by that. What percent of people in the study are male? So we have 266 males divided by an entire sample of 400. So that's 66.5%. Okay, try this one out, you guys. I'll give you guys 15 seconds. What percent of males are in rank 3? 80 people are males in rank 3. Divide by males. This one. So 80 males in rank 3 divided by all males. So we have 30%. And what percent of those in rank 3 are male? So be careful. Right now we're looking at all those in rank 3 are male. So 80 males are rank 3 divided by everyone in rank 3. So we get almost just over 2/3. How many females are in rank 2 or 3? That's easy. 2 or 3. So the addition rule again. Females, 45 plus 38. So 83. So it's only asking for how many. They're not asking for a percent. Okay, last one. What percent of females are in rank 2 or 3? So there's 83 of them are in rank 2 or 3. Divide by all females. So zoom it out for a bit. So it's 83 divided by all females. So 134. And you get 61.9%. I mean, you could also do like that, and then 45 plus 38, close bracket, and then divided by the total females. That also works. So you'll get the same thing. Any question on these? And just so you know, they asked these kind of things on the midterm, which is good news. It's not too hard. Okay, any questions so far? Okay, so let's continue on to the next page. Stat columns. Let's go quickly check if there's any questions here. Oh, so I attend to the chat room. Someone wants to see K58. What's K58? K58. Oh, here we go. So I divided, this is weird. I did 83 here, divide by the total females. But you can also do this. I add up 45 plus 38, put those in brackets, and then divide it by the total females, 134. Is there a shortcut for making a contingency table? Yes, with software. Yeah, I can't. Yeah, there's no quick way to summarize all these into a table. You have to yeah, it's fast because I already made this table in advance with the blank table, and then I use the Countifs functions. That's probably the best way to do it on the midterm. No, not the midterm, on the assignments. And the good news is on the midterm, and again, I'm talking too much about midterm. The midterm is they're not going to give you raw data like this on the midterm, and then you have to generate stuff. You don't have to count stuff on the midterm. You have to generate graphs on the midterm. Your job on the midterm is to analyze them, which is good. As good as the bad news, right? Drawing graphs and counting are easy. Analyzing is trickier, but once you get the hang of it, analyzing should be straightforward. Any other questions here? Okay, someone's asking, can you explain skewness again? Absolutely. Actually, let me switch to my notes now. And we'll talk about skewness. Okay. So I already talked about these, right? Mean, median, interquartile range, mode. So we covered all that. Let's talk about skewness. Dr. Berkowitz, after you write a midterm, he wants the grades distribution to be pretty symmetric and unimodal. We call that a normal distribution. So a normal distribution is symmetric, where the median and the mean are equal, and there's 50% on the left side, 50% on the right side. So basically, the professor wants the class average to be right there, and it has to be a reasonable class average, like a high 60 or a low 70. For a first-year course, that's what they want. And then 50% is higher than average, and 50% is below average. What if the data is skewed? Again, skewness happens when there are a handful of super small values or a handful of super large values that skews the distribution. When you have very few small values relative to the rest of the data, you're going to skew the data to the left when there's very small values. So these are small, extremely small outliers. I mean, they don't have to be outliers, right? They could just be very small values. So these are very small values. And to be clear, when we talk about skewness, we're pertaining to quantitative data. You can't talk about skewness when we talk about categorical stuff, right? If you talk about hair color, you can't say hair color is skewed to the red. That makes no sense. So skewness always talks about quantitative data. What's an example of data that's skewed to the left? What kind of situations where you're very small, very few small values? This could be an example, could be an easy exam, right? An easy exam means lots of people did very well. So you can see lots of people or students got high grades. And clearly that's more than 50% of the data. When you look at the area under the curve, it looks like a lot of students got high grades because the exam's easy. Unfortunately, there will always be some students who did very poorly, despite how easy the exam is. Please don't be those students. But these very few students did so poor, even though the exam's easy, and therefore they're going to skew the data to the left. And as a reminder, the skewness goes towards the direction of where those extreme values are. So because they're small values, they're dragging the data, skewing the data to the left. Okay. What's another example of data that's skewed to the left, where the majority are big numbers? Any other examples? Put them in chat. What kind of situation where you have people taking on large numbers? How about the sun run, where you have time? So the larger the time, the longer it takes you to complete a 10K run. And not to brag, every time I do a sun run, I'm in the top 25 percentile. But I'm getting older now, so I'm getting worse. Anyways, most people take pretty much a long time to complete the sun run. And then you have a few handful of super athletic people that take very little time to complete the sun run. So that skews the data to the left. And that's always the case in sun runs or most marathons. So the sun run, where most people are pretty average, they take an hour or longer to complete 10K, whereas there's always going to be these few people that finish it in like 20 minutes, which is absolutely insane. But there are those people, and I'm not those people. Does it make sense? Okay, let's talk about data skewed to the right. Here we have, this is an example where the population is very fit. And we use weight as the quantitative variable. And in this case, there are very few people who are overweight. So you have few large values relative to the rest of the data. So when we have a population where very few people are overweight and most people most people are in the lower end of the weight, then in this situation, data is skewed to the right. When there are a very small handful of large values, then the distribution is skewed to the right. So that's the example of skewed to the right. Any question on that? Okay. Let me get even more technical. When the data is skewed to the left, let's compare the mean and the median. The mean, like I said, is a non-resistant measure. I should go back to the table up here. And just to compare, the mean is the average value of the data, whereas the median talks about position, not the value. So the median is a resistant measure, whereas the mean is a non-resistant measure. It's very sensitive. So the median is a resistant measure of center, is not heavily influenced by outliers or extreme values, whereas the mean is very influenced by extreme values. So the mean follows the direction of the skewness. So if there is a very small handful of small values, that means the mean will be lower than the median. The median is the number right in the middle, where 50% is below the median, 50% is above the median. That's not the case for the mean. The mean follows the direction of the skewness. So in this case, when data is skewed to the left, the mean is lower than the median. And this is very important, you guys. This is always on the midterm. Conversely, when data is skewed to the right, you have the median here. And the mean goes crazy. It follows the direction of the skewness. In this case, the mean is greater than the median. So please make sure you write this down. When data is skewed to the left, mean is less than the median. When data is skewed to the right, the mean is greater than the median. So you can probably understand now that when data is normal or symmetric, excellent. That means the mean is equal to the median, assuming that is a unimodal distribution where there's only one mode. So when the data is symmetric or normal, the mean is equal to the median, given that is a unimodal distribution. Okay, any questions so far? Okay, so that's a quick review of skewness. Okay, so today, what time is it? Oh, good. So we have an hour left, which is good. We're going to use more formulas. We already completed the contingency table, and we already solved for the conditional probabilities. Next, we're going to solve for the stack columns, and then we're going to analyze and construct a histogram. Okay, do you guys want to take a 5-minute break, or you guys want to continue? I'm never tired. Raise your hand if you want a break. Okay, it looks like majority don't want a break. Okay, let's continue. Okay, let's do stack columns. And let's go back to our Excel. Let me move my Excel here. Okay, we're done with that. So we'll take a break from formulas. Now we're just going to construct stuff. Create a stack column bar chart comparing the distribution of ranks within males versus females. So what we're going to do is we're comparing the two genders, and the two genders are categorical, right? So we're going to have a bar chart, but this is more complicated than a regular bar chart because the bar chart will just show 2 bars, whereas a stack column is still a bar chart, but they show distributions within those bars. And to be very clear, we have bar charts are for categorical variables, whereas what kind of chart is for quantitative that looks like a bar? Histogram. Histogram are for quantitative data. That is super important. I'm going to put that in highlight. So bar charts are used for categorical data. Histograms, we'll talk about that next tonight. Those are for quantitative data. So you can see gender and rank, they're both categorical. Okay. Okay, now let's create a stack columns, and then we're going to make it very pretty. We're going to use row total percentages, and then we're going to stack them horizontally. You know what? Let's stack them vertically. Probably looks better. Doesn't matter. Let's stack them vertically. We're going to use the table from our descriptive stats. Let's grab that table and copy that. And don't just paste it, because if you paste it, it's going to look like this. It's going to be disgusting, right? It's not going to work. So you want to do control, right click, and then paste special. And then we're just going to paste the values right here. And it's only going to populate the values. Notice that the formulas are all gone. There's no more formulas in these. You should double click them all. There's no formulas because I only transferred the value, which is what we need. Okay, so we're going to do calculate the row total percentages. These are not percentages. They're just integers. So what I'm going to do is I'm going to copy this again and then paste it here again. And just go ahead and delete everything in the second table. And then we're going to calculate the row totals because we're going to compare the distributions of the ranks within each gender. So what we're going to do is we're going to calculate how many males are in rank 1 amongst all the males, because we're going to do the row totals percentages. So what you do is do this equal, click on this corresponding cell divided by the total of all males, and then do equal, and we got that. And that's too many digits, so I'm going to manipulate the number of cells, number of decimal places. Let's just do 4. 4 is always good. So double click. So all the males in rank 1 divide by all males, because we're just calculating percentages of ranks within the male group. And then we'll do it again for male rank 2, divided by all the males. There we go. And equal here, all the males in rank 3, divided by all the males. Great, look at that. And the row total must equal to 100%. Okay, any question on these so far? Okay. Because like I said earlier, because there are more males than females, there's twice as many males actually. It's kind of hard to eyeball the distribution based on these whole numbers, but it's a lot easier to compare percentages because all the percentages within each gender should equal to 100%. Now, are you going to start again for females, or is there a shortcut? So I could do equal female here, divided by here, but that's too much work, right? What you could do is highlight all of these 4 cells, copy those, and just paste it right there. And it calculates everything for the females. You see that? So this calculates this divided by that. This cell calculates this divided by that, right? I'm not sure how much time that saves, but a lot faster than re-entering all the same formulas. And then I can copy all this and paste that here. I mean, this is not as important. We're not going to use these numbers anyways for my stack column. I only care about the distribution here. Now, what do you notice here? So I'm going to make this less important. I'm going to make this, I'm going to gray it out there. This is not very important. That's too late. There we go. So look at this. Comparing the distributions between male and females, it looks like the ranks are pretty evenly distributed. It's not perfectly equal, but I can already, I'm already, like you can see that the ranks are pretty evenly distributed. So this is pretty good. But of course, in terms of equality, it looks like there are slightly more females in rank 1 and slightly fewer females in rank 3. So there's still a little bit of gender inequality here. Again, I use random number generator. I didn't make this up. I just used random number generator. So these are numbers I came up with randomly. So these are percentages. And the question now is we're going to do a stack column bar chart using these percentages. Okay, so what I'm going to do is I'm going to highlight these. So highlight these cells. Don't highlight. Actually, I'm not going to include the row total. Just highlight these ones. And Excel should be smart enough to figure out what kind of graphs it may recommend. So what I do is now go to why is the column total not the sum of E16 and E17? Where's that E16? Oh, okay. So here's the okay. So someone asked a question here. How come these two cells don't add up to this? Because we're using row totals. And that's a very good question, because on the exam, they're going to show you something like this, and they're going to ask you, are we using row totals or are we using column totals to calculate these? In this case, we are using row totals. So I'm making a note here. We are using row totals, not column totals. Therefore, the rows add up to 100%. The row percentages does that make sense? So since we're using row totals, the rows add up to 100%, not the columns. Now, if you're curious, since you guys are a smart class, why don't we do this again using column totals? So you know what, let's do this, row percentages. And now let's add a one for column percentages. I'm gonna make it blue. So these all add up. And now we're gonna make these add up, okay? Now the reason why I'm using, just to be very clear, the reason why I'm using row percentages, because I want to look at the distribution within each gender. So here, right? So here it tells us how distributed they are, the ranks, in terms of gender. So these are the distributions within males. This is the distribution within females. But when I do the column percentages, it tells me the distribution of gender within each rank. So look at this. So for males, I do this, 90 divided by what? Since we're doing column totals, I'm going to do 90 divided by 141 because I'm calculating percentages column-wise, if that's the word. Notice that the numbers are completely different. So now it's 96 divided by 141. And now it's 80 divided by 118. Completely different numbers. Notice that these numbers no longer add up to 100% if you do the rows, right? What does this tell me? This cell. This male 1 cell tells me that amongst those in rank 1, 64% are males. I'm going to write this down. So I'm going to do orange here. Oops. Let's do that. So this tells me amongst those in rank 1, 63.83% are male. That's what this orange cell tells us. What about this cell? Let's make that green. What does this green cell mean? This green cells mean amongst those that are male, 33.83% are rank 1. Notice that the language is completely reversed. So the top left cell in the row percentages tell me amongst those are males, 33% are in rank 1. Whereas this top left cell, when we do the column percentages, amongst those in rank 1, 63% are males. completely different language. So be very careful on the exam. And I'm glad you brought that up, Jasmine, because that's very important. So by adding up the percentages, find out which way it adds up to 100%. Then we know what percent, what we're doing, either row totals or column totals. Now, since we already started this, let's complete this. For females, I'm lazy. I'm just going to copy this and paste it. How come that didn't work? Oh, because I dragged it. That's annoying. My bad. Anyways, this 51 divided by 141. Can I copy this? Yeah, you can copy and paste that cell and put it here. And I promise you those two add up to 100%. There we go. So now you can see that they add up to 100% this way, column-wise, but not here. Okay, any questions? Okay, cool. So that's the difference between row percent and column percent. Okay, now we continue with our task. We're going to use, we're going to create a stat column using the row percent. So this one, this is just sidebar. But I'm glad we did that. That's awesome. Okay, so let's go back. I'm going to copy this. So what I'll do is I'll copy these so that Excel will generate based on gender, and then it will calculate the percentage of ranks within each gender. So where was I? We go to insert. And then you can, I love this function. When I learned Excel back in like 2003, this did not exist. This is called recommended charts. I love it. If you click on it, you can go start shopping and say, oh, which one do I think I want? Right? Oh, look, this is exactly what I want. This is a 100% stat column. It literally says that. And it's going to show me these stat columns. So let's click on this one. So this is stack columns based on row percentage. This is male versus females. And we're looking at distribution of ranks within each gender. Now, is this what we want though? Like the format, the style of the graph is what we want, but this is not what we want. Why? This is looking at, we're comparing three ranks and then the gender within, right? Male, female, female is orange, male is blue. That's not what we want. We want two columns, male versus female, with the ranks within those two columns. That's not what we want. So how do we fix that? You click on the chart and then right click it. And then go to select data. And please follow along, because this is not what we want. The style is what we want, but that's not what we want. And in this, you can switch the rows and the columns. It doesn't switch the calculation, just to be very clear. It doesn't switch the calculation. It just reverts what you want to show in terms of the graph. So click on switch row and column. And now everything's reversed. And then click on OK. And look at that. Now we have the male and females compared. And this row percent, we don't need this. So I can delete this. Whoops, that's gross. Wait. Let me try again. So insert. Where'd my graph go? Oh, I lost my graph. Anyways, this is what it should look like, where you have male and females, and then you have the ranks shown within each gender. So what I can make this extra fancy, and I can label, add data labels, and now you can see the percentages for each color, for each rank. And that corresponds to the row percentages. So looking at graphs like this is a lot easier than looking at numbers, because you can easily eyeball the distribution. So to me, it looks pretty equal. It could be more equal, but it doesn't look too bad. Let's see a question here. Someone says, can you repeat that again? Repeat what, sorry? Okay, let me try again. Where did my chart go? Let me do it again here. Okay, so I'm gonna do the chart again. Insert, and then what they recommend. We want this one. There it is. And we're gonna reverse the data. We're gonna switch it. And there we go. How come that was so much easier this time? So now that's how I compare males versus females and the ranks being distributed. And then if you want it to be fancy and add the extra elements, like you can do add data labels. Now it's going to label this, and it's going to label this, and it's going to label that. So right click and then add data labels. If you don't like all these digits, right, highlight all these and just reduce the number of digits as much or as little as you want. And for the final exam and for the midterm, they will specify their answers to be in specific number of decimal places. So if they want the answer in 4 decimal places and you provide only 3, for example, you will get 0 marks, just not to scare you, right? Just like COMM 290, you want to comply to the number of decimal places. Okay, any question on stat columns? Because I think this is one of the tricky ones to create on Excel without stat software. So that's why I want to cover this. And the other crazy one is histograms, which is not terrible, but very cumbersome. Okay, are we good? So that's stat columns. Okay. Next, we're going to do, so are the ranks evenly distributed between genders? I would say roughly yes. It's not perfect, but there's a term called statistical significance that you'll learn in closer to the midterm. Statistical significance is when you actually run a test to determine whether there's equality or not. So since we're not there yet, the best you can do so far in week 3 of a first-year stats course is just to look at a stat column and see if they're evenly distributed. To me, that looks pretty evenly distributed, but there's definitely room for improvement in terms of equality. I mean, if there's like 2% females in rank 3 and 88% of females in rank 1, definitely there's no equality there. So there's, right, then in that case, there's no equality. But looking at the stat column, right, more or less, it's pretty evenly distributed, but not perfectly. Okay, so far so good? Okay. Okay, now let's move on to the histogram, because I know I looked at your assignment. Like, honestly, to me, like the histogram took me a long time to generate, but it's pretty rewarding once you have that done. Okay. Okay, good. We're in the final tab now. And we still got more than half an hour left, which is good. So if you have extra time later today, and if you're not tired, we'll do some extra stuff. How many people have salaries greater than 100? Okay, greater than 100, not equal to. So if I'm 100, I should not be counted. So how many people have greater than 100? Oops, let me move that away. So we're going to do, I can make this a little bigger, sorry. We do Countifs. Let me do all caps. Countifs. And there's only one column to choose from, salary. And has to be greater than 100, not equal to, greater than 100. And don't forget the quotation. I always forget. Quotations greater than 100. Quotations. There we go. So let's go count anything greater than 100. And 167 are greater than 100. How many people have salaries greater than 100, but less than 165? Why do we give that a try? Greater than 100, but less than 165. So basically, we want this. Without, wait, not equal to, right? Okay, 10 more seconds. Greater than 100, but less than 165. So there's two conditions. And by the way, the first one, I use Countif with the S, but there's only one criteria, right? I could have done Countif with one criteria and do the same thing. And I'll still get 167. But don't forget, Countif is only for one criteria, whereas Countifs can still work if there's only one criteria. So when in doubt, you can always just use Countifs with the S. It'll still work. So I use both Countif and Countif with the S. It still works. Okay, so this one's clearly two criteria. So I definitely need to use Countifs. And highlight this, comma, greater, wait, don't forget quotations, greater than 100, comma, and the same column. And now it's comma, so quotation less than 165, quotations. So that will be my formula. Okay, I'll let you absorb that. And 152. Would it help if I do this? Would it help if I just like paste the answer, paste the formulas on the right side? Oops. There. Hopefully that might help you. So I'll leave the formula on the right side so that you know how to use it in the future. Okay, so how many people have salaries between 100 and 165 inclusive? So we are adding any values equal to 100, equal to 165, and anything in between. So give that one a try. I'll give you guys 15 seconds. How many people have salaries between 100 and 165? So 100 equal or greater. I know sound looks weird like this. Like that. Equal or greater than 100 or equal or less than 165. Okay, here's the answer. Countifs. And this column less than or equal to 100. Quotations. And then the same column. Quotations. So did I say should be greater than, right? Greater than 100. Sorry, it's greater than 100, and less than or equal to 165. Yeah, there we go. Let me double check the second one. Did I do it right? Yeah, that's right. Greater than 100, less than 165. Equal greater than 100, equal less than 165. So that's correct. So I'll put the formula here. Okay. Any question on these formulas? Isn't that great? No need to scroll and count with your hands. That will make you dizzy. Okay, now we're gonna complete the frequency table for salary. This part of my language is a pain in the ass because now you got to count. And again, I did all the dirty work. I already calculated, typed out all the bin sizes. And what is a bin, by the way? A bin is like a garbage bin. And a bin contains how many counts that falls within the intervals indicated by that bin. So for example, only one person falls between 200 and 250. If the salary values fall along the boundary, then put the observation into the smaller bin. So if it's 150, then put it into this bin, the lower one, not this one. So I already indicated the outliers. These guys, there's one here. And again, remember that guy who had 855, so they'll be put in here. So notice that there's a lot of zeros here, right? These are called empty bins. So these are empty bins. They're not gaps. Why do I say this? Because histograms cannot have gaps. Because you're dealing with quantitative data, right? Every value must be represented. So notice there are no gaps when you look at these numerical values, these quantitative values, but empty bins are okay as long as these bins are represented. So these are not technically, they're not gaps basically. They're just empty bins and that's okay. So that's why I say histograms cannot have gaps. Empty bins are okay, right? And this total is not a bin. It's just total. Okay, how many fall within 0 and 50? And again, if the value is 50, it should fall into this bin. If the value is 50, it should not fall into a second bin. So you got to make sure you do the equality correctly. So let's do that. Let's do Countifs. And then everything here has to be equal or less than 0, equal or greater than 0, or greater or equal to 0. And then the same column. And it has to be equal or less than 50, because we are counting 50. That's why I'm doing equal or less than 50, like that. So I'll let you guys absorb that. And there's only 4. So 4 of those fall into this bin. And I think it's helpful that I put the formulas here. So this is the formula for this corresponding bin. Okay, now for this one. Again, to be clear, if it's 50, 50 should be in that first bin. It should, and if you're 50, you should not be double counted. You cannot double count counts in histograms or anything. So Countifs. And this time, it has to be greater than 50, not equal to. So this is so important, greater than 50. Don't put equal sign here because it'll count 50 again if you're 50. So any value that's 50 is already counted in the first bin. You cannot count that again. So because any boundary values like 50 should be added into the lower bin of the two. So don't write equal sign here. It has to be greater than 50 or equal or less than 100. And that should be 229. And let me put the formula here. Okay, do you see that? Okay, I might be crazy, but I'm going to zoom in here. Again, if a salary values fall on the boundary, like 50, it will go into the smaller of the two bins. So if you're 50, you'll be in this bin, the lower one, not this bin. So that's why any value equal or greater than 0 or equal or lower than 50, including 50, will be this bin, whereas the second one has to be greater than 50, so that 50 is not counted because it's already counted in the lower bin. Okay, and then this one is Countifs here. And has to be greater than 100 or less than or equal to 150 and 136. Okay, almost done. And this one must be greater than 150. Oops. And then, oops. Less than or equal to 200, like that. 28. Yep, that's correct. And please make sure you understand these formulas and write it down, because I can't send you these solutions afterwards. So this is your chance to ask questions. Okay, so we know that there are a total of 400 observations. So my total, I'll just do sum, must equal to 400. I hope it is. Yes. So 400 total. So we know that everything is accounted for. And I do this because that will tell me if I accidentally double counted something. So if I double counted 50 into both of these bins, assuming there's a 50 value there, then my total will be greater than 400, which tells me, oh, maybe I double counted something. But since my total is 400, that gives me some relief to know that I did not double count anything. Okay, so it's a good habit to always calculate the total. So there you go. I mean, this only took us 5 minutes. Of course, on the assignment, you have to like create the frequency table, then you got to add them up, right? And I know the assignment's already done, but you'll notice that the Countifs function will continue to be very useful in future assignments. How do I know the total should be 400? Good question. Why don't we just do a quick count? So let's do a count without conditions and just calculate the entire column. And I know this 400. So that's how I know that the total observation is 400. And I think we established that in the beginning, right? Did we? Yeah, there we go. How many people are in the study, right? And we already did a count for all the observations. So that's how I know it's 400. There are 400 in the study. Make sense? Okay. So I'm glad you're asking questions on the chat. That indicates to me that you're listening and you're still here. Okay, any questions with histograms? Oh, we haven't drawn one yet. It asks here later, is it skewed to the left or right? We already know it's skewed to the right, but let's prove that by actually making a histogram. How do you know it's skewed to the right? You can see all the data, most of the data are a bit lower than 200, and a small handful are on the right side. So that tells me there are a very few handful of large numbers, but the majority are low numbers relative to each other. So what you do is you highlight all the bins, including the titles, but don't include the total. Otherwise, Excel will think 400 falls into the total bin. Again, total is not a bin, so don't highlight that. And unfortunately, there's no histogram choice on Excel. So we have to choose something called a bar chart, which again, technically is not a bar chart reserved for categorical data, but that's fine. Let's choose column. Actually, you know what? let's take advantage of the recommended charts. I always laugh because when you look at a recommended chart, it looks like you're going to a restaurant. They're recommending you certain dishes. So this one looks good, right? That looks like histograms. And that looks pretty insane, but here we are. And you can see the majority of the data on the left side and very few on the right side. And if you really zoom in, can you see? You can see that one guy here, the 855, the very tiny bar right there. That's an outlier. Again, outliers are extreme values, either to the left or the right side of the data. Now, this is hideous because I hate the title. There are no labels. And look at that. There's gaps. Histograms cannot have gaps. If this is 0 to 50, and this is 50 to 100, then mathematically, there should be no gaps between 50 and 50. So we have to close the gaps. So that's the first thing I need to do. Otherwise, I can't sleep tonight. So let's close the gaps. And how do you do that? Double click on the cells or double click on the bar. And this menu should pop up. And this is gap width, right? Make it 0. Please make it 0. Otherwise, I can't sleep. Okay, so double click on the bars and then click 0. And the bars are now closed. Beautiful. I feel better now. And it's kind of gross because the bars are now like meshed together. So I'm gonna add lines to it. And we call that borders. And you can make the border any color you want. I'm gonna make it, I'm not very artistic. I just want a color. Let's make it black. Okay, that looks better, right? It's got some bars now. Now we're gonna label this histogram for salary. And the question is, how the heck do you add labels for the axes? Let me know if I'm going too fast. Click on here, see add chart element. And to reach the top left corner, make sure you're on chart design here. Chart design, and then click on add chart element. And then you want axes titles for the horizontal, which is the bottom part, and then the vertical on the left side. So let's do the left side first. And the left sides are literally just counts or frequencies. It's kind of hard to type this way. You can also call it counts. This means, right, there are 229 values that falls within the 50 to 100 size bin. And now let's add the axis title for the horizontal. And you can simply call this bins. You can also call it salary. Now this is gross. I don't like how this looks. How do I make the bins prettier, these numbers? Because that looks pretty wild right now. So I don't like this. You can decrease the font, but it's already pretty small. I mean, that doesn't really help, right? What you could do is to click on here. I think it's this one. Axes. Where did I go here? Oh yeah, this symbol here. You can make them rotate. So I'm going to rotate. The assignment asks you to rotate. I mean, my assignment asks you to rotate to 270 degrees. So let's click on this one. And that looks a lot better to me. It's not beautiful, but it's a little bit better and less crowded. Sorry, Karen asked, where do you find the gap width? Simply double click on the bar. Double click it, and you can see gap width right there. So you can increase the gaps, which please don't do that. Or you can close the gap. We don't want gaps in histograms. No gaps in histograms. Bar charts for categorical variables, no problem. Because categorical variables are like Honda, Toyota, BMW. They're just categorical. So gaps in between categories, no problem, because we're not doing any math here. So that's how you do gap width. You just literally just double click on the bars. So make sure you close the gaps, because the prof told you to close the gaps for the assignment. So there's our histogram. It's beautiful. The title, I labeled the axes. I rotated the bins, as you can clearly see the outliers. If you're extra fancy, you can right-click the bars and add data labels. And now it tells you the counts for each of the bins. So now, because the one value here is very unnoticeable, now that I see a 1 here, I know there's one value in this large bin. So you right click it and add the data label. So all these are just aesthetics, but you need to do all these for full marks. Any questions with the histogram? I mean, if I use software like Minitab, this will literally take me 2 minutes or less. But right, you can't use software, I guess. Any question on histogram? Good, we're on schedule. This is pretty good. Okay, I don't see any questions. Do you want to see me do this on software? And actually, no, forget it. You won't learn anything if I do software. Let's go. And it's always a good habit. Once you feel like you're done, please go back to the question to make sure you answered everything, because this will not give me full marks. Why? Why will I only get 4 out of 5 here? Because I'm not done. I didn't do everything I'm being asked to do. Add a title, I did that. Label the axes, I did that. Make the text rotate 270, I did that. Make the bars green. I know it's stupid, but the reason I did that is to make sure to train you to always go back to the question to make sure you answered everything. And we did not here. We want to make the bars green. How? Go back to the bar, double click it, click on the, a paint bucket, and I'm gonna make, and not the border, I want the fill to be green. And I'm not picky what green you use here. Let's use this one. There we go. Now it's green. My second favorite color. My favorite is blue. Not that you care. So that's our histogram in green. So we fulfilled everything we need to do. Let me know if you want me to repeat anything. Okay, it looks like you guys are pretty satisfied. Okay. So the histogram is skewed to the right, right? It's skewed this way. Is there an outlier? Absolutely. Yes. Okay. Any questions so far? Okay, I'm going to make it open-ended now. Since we have extra 14 minutes, ask me anything, Excel related, stats related. I'll be happy to answer. How do you rotate the x-axis again? No problem. Click on the axis, double click it. And now you see format axes right there. And click on this weird one where it has, when you have size and properties, I guess that's what we call it. Is it this one? Yeah, and then click on rotate the text, and you can choose any of these. The word stack sounds fun, but it's actually horrendous. If I click on stats, look how gross that is. So don't do that. And then if you want to rotate horizontally, it's not terrible. I mean, that's not bad. But the assignment says rotate to 270. So that's how you rotate the bins. How well do your students do on the midterms and final exams? Not to brag, my last group of students, no one got lower than B-. Well, based on the students I tutored one-on-one, I don't know what the grades my class got. But not to brag, I like my crash courses. I've been doing my crash courses for many, many, many years. And because I tutor students from your class, I have a good sense of what the exam will cover. And just to be very clear, this is a free session. Next week is also free. Make sure you bring a friend or two, right? Preferably 5, so that I get more exposure and more students learn from me, right? How much will these classes? I don't know how much the midterm crash courses cost. I don't set the costs. But yeah, my crash courses are typically 6 hours, but we're adding a bonus 1 hour because I don't like to rush too much. Because based on I'm obsessed with stats. So based on my stats last year, I got pretty good teaching reviews, but the negative feedback is that I go too fast sometimes, which I get. So we're going to add an extra free hour to the crash course so that I don't go crazy fast. After session 2, is there a fee for these? I believe yes. If you want to save money, you can buy a package for the entire semester so that you're only paying like on average a couple bucks per session. I think a la carte per week, I think it's 30 bucks. But you definitely save money if you buy it for the entire semester. So if you like this, please do buy the package. But yeah, next week is also free. So if you're not sure about me yet, try me again next week. Make sure you bring some friends. What's the best way to prep for 291? And as a reminder, you're not going to be graphing on the midterm. They don't care how good or how pretty your graphs are. Your job on the midterm is to analyze the graphs. So they'll give you box plots. They'll give you, box plots. We still have to cover that. They'll give you graphs. They'll give you histograms. They'll give you scatter plots, which you'll learn next week, I think. Did you guys learn scatter plots yet? Sorry, I had a lot of caffeine in me. Soon wine. Scatter plots are great. You'll be doing that for next assignment. So hopefully by next week or by week 3, we'll start learning things before the assignment so that you'll have the skills to complete the assignment that's coming up versus right now where you're learning stuff that you already submitted. But again, these formulas that you learned today are still relevant. So okay, so we still haven't done this yet. So this is the histogram that I use using Minitab. Looks exactly the same, right? But the Minitab function I use different bins, and the limitation is that it doesn't show all the bin sizes. So this is from Minitab, and it's a lot faster, but it doesn't show as much detail. So you can't submit this on the assignment. Here's a box plot. How can you tell this is skewed using looking at a box plot? Here's an outlier, right? Because that's 855. So this is either a typo or this guy is legit earning that much, which is crazy. He needs to be audited. Can you see this is skewed to the right? If I look like this is the smallest number. This is the largest number, right? And you can see skewness. You should look at it this way. You should rotate your neck 270 degrees like we did for the histogram. You can see this is skewed to the right. So when you're looking at a histogram, I can obviously see skew to the right. And if I look at a box plot, I can also see that the data is skewed to the right. So on the midterm, right, your job is to understand skewness, measurements, data. Your job is not to create formulas. Your job is not to move axes or label stuff, right? That's their job in the assignment. The midterm, your job is to analyze data, which is good. I hate graphing. I prefer analyzing, but that's just me. Okay, any other questions? I see another. Ooh. Will you be doing tutorial sessions in the summer, one-on-one tutoring? You can ask me later. You can email me about the summer tutoring. I don't believe stats. Well, I don't know. Stats is not. I think it is offered in the summer, but obviously most students are taking it right now. But yeah, talk to me about summer sessions. Is it even worth it to read his textbooks? Please do not skip class. Berkowitz is a great professor. Don't skip class because you notice how much he covers in one session, right? And are his classes live or are they pre-recorded? If you miss a class, can you still watch the lecture? I don't know how he does it. But please don't skip class. Okay. The weird thing, okay, when I took this course a billion years ago, the tutorials does cover Excel, whereas your class doesn't cover Excel. So I don't know how they expect you to do all this without Excel knowledge. So this is why I'm here. Okay, good. He records them. Why is the IQR so long in this case? What does that represent? Oh, okay, good question. Where's the IQR here? Let me erase this. The IQR, I'm going to make this green. Let me zoom in. This is your IQR. It's not long. is actually very narrow. Because if you look at the IQR, it's very narrow because we're looking at it this way. I know it's kind of weird. The IQR is very narrow. Why is that? Because 50% of the data are relatively small numbers. If you go back to the frequency table, right, you notice that there's a very narrow gap between, right, where 50% of the population, or not population, 50% of the sample fall within the IQR. Very few are large numbers. That's why the IQR is so skinny when you look at it from bottom to left. It's not wide. It looks wide looking at this way, but that's not how you look at the data. Could you explain what Berkowitz means when data is strong, moderate, or weak? Are you talking about correlation? Strong, moderate, and weak. I think that pertains to correlation. Yeah, we don't talk about how strong the IQ are. That makes no sense. So when we talk about strong, moderate, or weak, I think he's talking about correlation. And we have 5 minutes. So let's talk about correlation since we're on that topic. And this will be useful for the next assignment. Let me go open a blank page. So when they ask you for strong, moderate, or weak, I think he's talking about correlation. Now, what can we correlate? We correlate between two quantitative variables. Everything we did today, histograms, box plot, we're only measuring one quantitative data, which is salary. But what happens when we have two quantitative variables? You can actually compare if there's any relationship or correlation between those two variables. What can we correlate? Let's continue with salary. And what can we add in? What's another quantitative variable? Years of education. We have the X variable and we have the Y variable. Both are quantitative variables, number of years and your salary, right? So years is quantitative, salary is also quantitative. So when you have two quantitative variables, you can plot something called a scatter plot, where Y is on the Y-axis, X is on the X-axis, and you have education on the X-axis, and you have salary on the Y-axis. Hopefully, the more years of education correlates to higher salaries. I hope so. Otherwise, why are you here? So the more education you have in terms of years, the larger your salary. Here we have a positive correlation. So we can establish that hopefully the more years of education correlates to higher salary, which relates back to Grace's question. When do we talk about moderate, strong, or weak? You look at how tight the scatter plot is. This looks like moderate correlation. So I can say positive, moderate correlation. Because the scatter plot is still pretty scattered, meaning there's a lot of exceptions basically. And this is sad, okay? Look at this guy here. What if you're this guy, this green dot? You have lots of education, but you have low salary. That's sad. That's an outlier. And then you have this guy, let's add another dot. This one. This is also an outlier. This guy scored. He has a high salary and low education. He didn't go to school and has a high salary. What kind of people are those? I think people whose dad or mom are CEOs or owners of this big company and they just inherited this company. So that, or this guy is an entrepreneur. He or she just finished high school, did not go to university, but made big bucks because he or she made smart decisions, right? It's possible. You can, right? But the point of scatter plots is to look at the relationship between two quantitative variables. Anyways, let's go back to in terms of strength. Look how tight this is. And we'll wrap up after this. Here we have positive and strong correlation. Meaning that the correlation is so tight and strong that there's not many other things that could explain the relationship between education and salary. And let's do this last one. Let's call this positive. But let's make it a very weak correlation. And I'm going to draw like this. It's a complete mess, but you can still kind of draw a positive slope. So that's the difference between moderate, strong, and weak. The tighter the scatter plot is, that illustrates the relationship between X and Y, the stronger the correlation. That's pretty much it. Does that make sense? Okay, last question before you guys go. What would no correlation look like? No correlation means you don't know, it's so messy that you have no idea how to draw the best fit line. It's just complete scatter, complete randomness. And what's the example of no correlation? The cost of your, this is an example, the cost of your calculator and your grade. So the more expensive your calculator is, does nothing to explain your grade, right? It's your brain, not your calculator, but right, that's just a terrible example between X and Y where there's no correlation. It's complete scatter. Okay, good. So we learned a lot today. Time flew. I'm glad we had extra time to cover some extra stuff. I hope you guys enjoyed this tutorial. I know it's Friday night, so thank you for coming here. Before you go, you can leave now, but I'm gonna add a link so that you can provide some feedback about this. This is my first tutorial, but if you want to stick around for 1 minute, sorry, let me grab that link, because I want to know if you guys can continue to come here on Fridays at 5:30 or not, and any other feedback you guys can provide. Let me copy this link. Sorry, one sec. Okay, so this is the link. Please take 30 seconds to provide feedback, and any feedback you give me will help me make future tutorials better, because if you start paying for this, of course I want you guys to give you the best service possible. So my goal is to every week help you with the assignments, but also prepare you for the midterm. And you'll notice that we'll switch gears once we get to the crash course, when we get closer to the midterm. But thankfully that's not until early March, right? Yeah. My brain still thinks it's 2020. Oh. You don't see a link? Let's see. Oh, sorry. There you go. So here's the link. It takes literally 20 seconds. I appreciate your feedback. So hopefully you guys enjoyed today. I'll stick around for another 5 minutes if you have any general questions, but yeah, enjoy your weekend actually.